Hello everyone. In this lecture, I am going to discuss about the methods of solving linear equations, especially non-homogeneous linear equations. And in that, we will see mainly Cramer's rule and Gauss-Jordan method. In the previous lecture, we have seen how to find out inverse of a matrix already. So, how can we solve a linear equation with the help of Cramer's rule and Gauss-Jordan method? We will see today. Let us start our session with Cramer's rule. What is Cramer's rule? These are the three given linear equations which are non-homogeneous. Non-homogeneous and homogeneous just have a small thing like homogeneous means power of the variable will be same. But here power is 1, power is 1, power is 1. D1 is not a variable, it is a number. So here there is no variable, here variable's power is 0. So you can tell that it is non-homogeneous. Then how can you find out the solution, common solution for these three? Okay, that is nothing but, first of all, we will find out a determinant for the coefficients of x, y, z. Okay, coefficients of x, y, z, here the z is missing. Okay, coefficients of x, y, z, we will find out determinant. If the determinant is not equals to 0, then we can find out the solution, and the solution is unique. Okay. Yeah. If the determinant, suppose you got 0, then what you need to do? You need to find out d1, d2, d3, delta 1, delta 2, delta 3. We call as delta 1, delta 2, delta 3. What are these delta 1, delta 2, delta 3? We'll see. At least one is 0 means you will have infinitely many solutions. If none of them, d1, d2, d3, if none of the numerator is 0, then you can tell it is not having solution. What is this delta 1? Understand, we have here delta, and delta 1 is nothing but replace the first column with d1, d2, d3. You will get another determinant d1, d2, d3, and write the remaining b1, c1, b2, c2, b3, c3 as it is. This is delta 1 or d1. Delta 1 or d1. You may call it as dx. Then delta 2. What is delta 2? You will replace the second column with d1, d2, d3. So first and last columns will come as it is. A1, C1, A2, C2, A3, C3. First and last columns you have written as it is. And the second column will be replaced with D1, D2, D3. So D1, D2, D3. This is delta 2. And what is delta 3? Delta 3 is nothing but first two columns as it is you will write, and the third column will be replaced with D1, D2, D3. So I can write here like A1, B1, A2, B2, A3, B3. And the third column is replaced with D1, D2, D3. D1, D2, D3. This is how we will find out delta 1, delta 2 and delta 3. And we will use this small operation to find out x, y and z values. Okay, let us try to understand this with the help of a small example. They have given three equations for us and we wanted to find out x, y and z values. First, what we need to do? We need to find out the delta. Here write the coefficients of x, y, z. 1, minus 3, 2, 3, 4, 1, minus 4, 2, minus 9. If you find out delta for this, you get 1 into 4 9 36, minus 36, minus 2, minus 38. I am writing at a time. Minus into minus plus 3 into 3 9s 18 plus 4. It will be 3 9s 27 plus 4. Minus 27 plus 4. Minus 27 plus 4 plus 2 into 6 plus 16. So if you solve this, what we will get? Minus 38 minus 23 3s minus 69 22 2s 44, which is yeah 44 plus 44. So final result will be minus 63. So you found delta is not equals to 0. So there will be unique solution. Now find out delta 1. How to find out delta 1? The first column will be replaced with the D1, D2 and D3. So I will write D1, D2 and D3 now. 8, 5, 2. Remaining two columns as it is will come. Minus 3, 2, 4, 1, 2, minus 9. Calculate the determinant for that. It will be 8 into 36 minus 2 minus 38 we will get, plus 3 into minus 47 we will get, then plus 2 into 5 to 10 minus 8 2 we will get. If you simplify this, we will get final answer like minus 441. Find out delta 2. Second column will be replaced with D1, D2, D3. So first column, last column, write as it is. 1, 2, 3, 1, minus 4, minus 9. The middle one will be replaced with D1, D2, D3 values. It is 8, 5, 2. Find out the determinant for this. We will get, I have calculated. We will get the determinant as 189. No need to find out the determinant 3. We will use a small trick to find out the z value. How you will find out x, y, z? We already know x is nothing but delta 1 divided by delta. Delta 1, how much we got? Minus 441 divided by delta minus 63. Okay, minus will be cancelled. 63 ones and 6 sevens 42. Yeah, it will be we can cancel with 7 times. It will be 7. Then what is y? Delta 2 by delta, which is 189 by minus 63. 63 ones, 63 threes. So we will get minus 3 here. We got x value as 7, y value as minus 3. Substitute these two values in any one of the equation. This is first one. I am taking first one, which is x minus 3y plus 2z is equals to 8. If you substitute the values in this, in the place of x it is 7, minus 3 into minus 3 is plus 9, plus 2z is equals to 8. 2z is equals to 8 minus 16. Add these two and send another side. 2z is equals to minus 8 and the value of z is minus 4. So x value is 7 and y value is minus 3, z value is minus 4. This is what the solution for the given equations by using Cramer's rule. Now let us see what is Gauss-Jordan method. Okay, we will write all the coefficients and this constant values in a augmented matrix, and we will convert that augmented matrix into this particular form where alpha beta are the values of x, y and z. You can see here some description how to reduce it into this particular form using row transformations. Okay, If you want, you can take the help of these particular steps. So it will be easy for you to find out this 3 by 3 matrix. First, we will focus on these two elements. Hope you all can see here these two elements. In the second step, we will focus on these two elements. In the third step, we will focus on C1, 3 and C2, 3. Okay. Okay, let us understand this method by using a simple example. First, we need to write augmented matrix. I am going to write a matrix over here. Okay. 3, 1, 4. First, I am writing 3, 1, 4, 2. 1, minus 1, 2, minus 1. Here there is no x variable, so I can write here 0x plus. So which is nothing but 0, 2, 1, minus 4. This is the augmented matrix which we have written. Now what we need to do? In our first step, we should make this particular element and this element 0. Already this element is 0, so we no need to worry about row 3. We need to think about row 2. Okay. So what I will do here, I will transform row 2 with 3R2 minus R1. Hope everyone understood. If I do like this, 3 into R2, 3 into 1 is 3, minus 3 will become 0. Okay? Hope everyone understood. Then, so if we change it, what we will get? We will get the matrix like this. Okay. The matrix is, first row we are not changing. 3, 1, 4, 2 as it is will come. Second row we are changing. R3, 2. 3, R2. 3 into this will become 0. Then minus 4. This is minus 3. Minus 1 is minus 4. 3 to 6 minus 4 is 2. Minus 3 minus 2 is minus 5. And R3 we will write as it is 0, 2, 1, minus 4. Yeah. Now you just observe this particular spot where the both elements are 0, 0. In the next step, what we need to do here, this element and this element, we need to make them 0. How we will do that? How we will do that? Simply, R1 we are going to change. R1 is nothing but 4R1 plus R2. Then what will happen? 4 into 1 is 4, minus 4 will become 0. Then how you will change this one? R3 we will change as 2R3 plus R2. Hope this is clear. Yeah, I will write the result over here. R1 we are changing like 4R1 plus R2. 4 3 is 12. So I will write 12. Here second element 4 minus 4 will become 0. Third element 4 4 16 plus 2 it will be 18. This one 2 4s 8 minus 5 it will be 3. We are not changing R2, so write the R2 as it is 0 minus 4 2 minus 5. Then third row we are changing 2R3. 2 into 0 is 0, so we can write as it is 2 2's 4 minus 4 will become 0. Then 1 2's 2 plus 2 it will be 4. Then 4 2's 8 minus 8 minus 5 is minus 13. So we successfully made these two also 0. Now we wanted to change in the next step this one and this one 0. So we will focus again on R1 and R2. Okay. So I will change here. R1 tends to 2R1 minus 9R3. You know why? That time what 2R1 means? 2 18s 36, 4 9s 36. 36 minus 36 will become 0. Then R2 tends to 2, R2 tends to, not R2, it is R3. We need to change the 4, not 4, R2 only. Yeah. R2 tends to 2R2 minus R3. 2 to 4 minus 4 will become 0. Okay. To change these two into 0, we are taking the help of the third row. To change these two, we are taking the help of second row. To change these two, we took the help of first row. Understand the pattern, so it will be easy for you. Now, if you do the transformation, what we will get? We will get here like R1 we are changing 2R1 minus 9R3. 2 12s 24. This is 0. This is 0. Then here we will get 100. 2R1 means 2 3 6 minus into minus plus 9 13s. Okay, it will be around, not around, exactly 123. Then 0. R2 also we have changed 2R2. 2 to 4. 4 to 8. So we will get here minus 8. Here 0. 2R2 means minus 10. Minus 10 plus 13 is 3. Okay, this is 0, 0. The 4 as it is will come, minus 13 as it is will come. Now you just see here, it is 24. We got diagonal elements here. Remaining these 3, that these 3 are zeros. Now what we need to do? I will change R1 as R1 by 24. R2 as R2 by minus 8. R3 I will change as R3 by 4. Okay, that time what I will get? I will get 24 by 24. R1 by 24, not 24 by 24 will become 1, 0, 0. It is 123 divided by 24. Okay, and the second row 0 minus 8 by minus 8 is 1, 0, minus 3 by 8 we will get here. Third row we are dividing with 4, so this is 0, 0, 1, minus 13 by 4. Now you just observe these 3 columns, we got one identity matrix. Okay, then you will tell x is nothing but 123 divided by 24. Think we can cancel this with the third table. 3 8s 24, 3 4s 12, 3 1s. So we will get 41 by 8. Then what is y value? Y is minus 3 by 8. We can't change it because they are co-primes. Z is minus 13 by 4. And this is how we will find out x, y, z values using Gauss-Jordan method. If there is any doubt, you just mention in the comment section. We will discuss it in the next video. Thank you so much.